morning, students. In the last class, we were discussing about the grouping of capacitors. Okay, that is, we discussed the capacitors in series. Okay, now we will start with the capacitors in parallel. Okay, capacitors in parallel. Now discuss now. First of all, what is the difference between series combination and parallel combination? Series combination ಮತ್ತು parallel combination difference ಏನು ಮತ್ತೆ ಹೆಂಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ? See, end to end connection is called as series combination. ಅಲ್ವಾ? In this series combination, the capacitors are connected between the different points. ಬೇರೆ ಬೇರೆ ಪಾಯಿಂಟ್ಸ್ ನಡುವೆ capacitors ನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರು. ಇವಾಗ ಏನಾಗುತ್ತೆ, ನೀವು ಎಷ್ಟೇ capacitors ನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರು ಕೂಡ whatever may be the number of capacitors, you must connect them between any two points. Okay, so that the potential difference across each of them will remain the same. Potential difference between each of them will remains the same. ಇಲ್ಲಿ C1, C2, C3, here C1, C2, C2 ಅಲ್ವಾ? For that ನಾವೇನ್ ಮಾಡಿದ್ವಿ, ಬೇರೆ ಬೇರೆ ಪಾಯಿಂಟ್ಸ್ ಸೇಮ್, ಪೊಟೆನ್ಷಿಯಲ್ ಸೇಮ್. here charge divides, charge ಏನಾಗುತ್ತೆ, ಡಿವೈಡ್ ಆಗುತ್ತೆ, such that the total charge is sum of the individual charges. That means the total charge on the combination of the capacitor is equal to the sum of the charges on individual capacitors. Here charge remains the same on each plate of the capacitor. Applied potential is given to the combination is distributed among the different capacitors, so that the applied potential is equal to the sum of individual potentials. Okay, so we have V is equals to V1 plus V2 plus V3, and in this we have Q is equals to Q1 plus Q2 plus Q3. I hope you understood this. Okay, yes. Now ಈಗ one ವಿಷಯ ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು, capacitors are said to be connected in parallel if they are connected between the same two points, so that the potential across each of them will remains the same. Okay, ಅವು ಮೂರು capacitors ಮೇಲೆ potential same ಇರುತ್ತೆ. Okay, and the charge on each capacitor is equal to, the total charge is equal to the sum of individual charges. Okay, ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು ರೀ. Yes, capacitors are said to be in parallel if they are connected between same two points. Okay, ಯಾವುದೇ ಎರಡು ಪಾಯಿಂಟ್ಸ್ ಗಳ ನಡುವೆ ಎಲ್ಲ ಕೆಪಾಸಿಟರ್ಸ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಅದನ್ನ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಅಂತ ಕರೀತೀವಿ. Yes, here potential difference across each capacitors, potential difference across each capacitors is same. Okay, and is equal to the applied potential. Okay, is same and is equal to applied potential. ಅಂದ್ರೆ ನಾ ಏನು ಅಪ್ಲೈ ಮಾಡಿರ್ತೀವಲ್ಲ ಆ ಪೊಟೆನ್ಷಿಯಲ್ ಮತ್ತೆ potential difference across the each capacitors. Okay, ಎಲ್ಲಾನು ಸೇಮ್ ಇರುತ್ತೆ. Then the total charge, okay, is equal to sum of charges on individual capacitors. These you should note this. Okay, if Q is the charges developed across the combination, if Q is the charges developed across the combination, then is equals to sum of the charges developed on individual capacitors. Okay, you should note all these things. First, series ಒಳಗಡೆ ಇದೆ ಅಂತ ತಕ್ಷಣ ಅವೆಲ್ಲ capacitors ನ ಒಂದೇ ಪಾಯಿಂಟ್ ಗಳನ್ನ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ. ಮತ್ತೆ potential difference across each capacitor is equal to the applied potential difference. The total charge is equal to the sum of charge on individual capacitors. Okay, yes, this is what the main important points regarding the capacitors in parallel. Okay, now we need to derive an expression for equivalent capacitance in parallel. Okay, parallel combination ಒಳಗಡೆ ಏನು ಆಗುತ್ತೆ, what is the equivalent capacitance ಅನ್ನೋದನ್ನ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. Okay, we need to draw the diagram. The diagram draw ಮಾಡಬೇಕು. So consider three capacitors. Okay, C1, C2, C3 connected in C1, C2, C3 connected in parallel. Okay, ನೀವು if you want ನೀವು ಬ್ಯಾಟರಿನ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೋಬಹುದು, ಇರಲಿಲ್ಲ ಅಂತಂದ್ರೇನು ಜಸ್ಟ್ ಆ ಥರ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿದ್ರು ನಡೆಯುತ್ತೆ. This is the total potential difference. It is connected between the 2 points C1, C2, C3. Okay, all of them are connected between the same points, but Q1 with the charge developed on C1, Q2 with the charge developed on C2, and Q3 with the charge developed on C3. Okay, yes, this is the applied potential difference V. Okay, yes, to explain the diagram, consider three capacitors C1, C2, C3 are connected in parallel between 2 points A and B. Okay, ಅವೆರಡು ಪಾಯಿಂಟ್ಸ್ ಗಳ ನಡುವೆ ಪ್ಯಾರಲಲ್ ಒಳಗಡೆ ನಾವು ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ. ಹೌದಾ? Yes. Now let V be the potential difference. V be the potential difference applied across the combination. Okay, applied across the combination and is equal to potential difference across individual capacitors. Okay, see here, the applied potential V is same as the potential difference on the individual capacitors. Okay, now because of this, charges developed on the capacitors. Okay, let Q1 be the charge on capacitor C1, Q2 be the charge on capacitor C2, and Q3 be the charge on capacitor C3. Okay, such that what happens here? You know that the applied potential difference is same, but due to this applied potential, Q is the charge developed across the combination. Charge developed across the entire combination. This Q is equals to Q1 plus Q2 plus Q3. You can call this equation 1. That means the total charge on the combination of the capacitor is equal to the charge on individual capacitors. Q is equals to Q1 plus Q2 plus Q3. Okay, fine. Now, you know that C is equals to Q bar V, which implies Q is equals to C into V. Okay, so Q is equals to C into V. Therefore, Q1 is equals to C1V. Okay, what you are going to write? Q1 is equals to C1V. Q2 is equals to C2V. Q3 is equals to C3V. Okay, now you can call this equation 2. Okay, C1V, C2V and C3V. Okay, Q1, Q2, Q3. Now, substitute Q1, Q2 in equation 1. Okay, ಅದನ್ನ ಏನು ಮಾಡಿ equation 1 ಒಳಗಡೆ substitute ಮಾಡಿ. Q ಆಗಿ V1, V2, V3 ಅಂತ ಬರಿಬೇಡಿ. It is parallel. Potential remains the same. ತಲೆ ಒಳಗಡೆ ಓಡ್ತಾ ಇರಬೇಕು ಯಾವಾಗಲೂ. Okay, therefore Q is equals to C1V plus C2V plus C3V. Okay, now Q is equals to C1, and you can take a common V, C1 plus C2 plus C3. Okay, you can call this as equation 3. Okay, Q equal to C1V plus C2V plus C3V. Therefore, Q is equals to V into C1 plus C2 plus C3. Now, if the combination is replaced by an individual, ಅಥವಾ we can call it as equivalent, replaced by an equivalent capacitor of capacitance CP. ಅಂದ್ರೆ equivalent capacitance. ಏನದು equivalent capacitance ಅಂತಂದ್ರೆ here equivalent capacitance ಅಂತಂದ್ರೆ it is the single capacitance ಅಥವಾ it is a single capacitor that stores the same amount of the charges as that of the combination. ಈ ಇಡೀ ಕಾಂಬಿನೇಷನ್ ಒಳಗಡೆ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಸ್ಟೋರ್ ಆಗ್ತಾವಲ್ಲ ಅದಿಷ್ಟು ಚಾರ್ಜಸ್ ಒಂದೇ ಕೆಪಾಸಿಟನ್ಸ್ ಸ್ಟೋರ್ ಮಾಡಿಕೊಳ್ಳುತ್ತೆ. ಓಕೆ, ಅದನ್ನ ನಾವು ಇಕ್ವಿವಾಲೆಂಟ್ ಕೆಪಾಸಿಟರ್ ಅಥವಾ ಇಕ್ವಿವಾಲೆಂಟ್ ಕೆಪಾಸಿಟನ್ಸ್ ಅಂತ ಕರೀತೀವಿ. ಓಕೆ, ಸೊ ದಿಸ್ ಕಾಂಬಿನೇಷನ್ is just replaced by another capacitance CP. ಬೇಕಿದ್ರೆ ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನು ಕೊಡಬಹುದು. This is the V. Okay, because of that, it stores the same amount of charges. The basic definition of capacitance, I mean equivalent capacitance, is it has to store the same amount of the charges. Okay, therefore here we have Q is equals to this Cp into V. Okay, we have Q is equals to Cp into V, means the equivalent capacitor stores the charges Q. Cp is the capacitor in parallel. V is the applied potential. Therefore, from equation 3 and 4, this is the number of charges from the combination. This is the number of charges or amount of charges from a single capacitance. Both are going to be same. Okay. From equation 3 and 4, we have CPV is equals to V into C1 plus C2 plus C3. Okay, VV gets cancels out. Therefore, CP is equals to C1 plus C2 plus C3. Okay, this is the required derivation. Thus, the effective capacitance in parallel combination is equal to the sum of capacitance of individual capacitors. Okay, CSA ಹೇಳಿದ್ವಿ ನಾವು, reminder not only reciprocal of the capacitor in series is equals to sum of reciprocal of individual capacitances. Reciprocal of ಅಂತ ಹೇಳಿದ್ವಿ. ಇಲ್ಲಿ ಏನು reciprocal ಇಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಆಡ್ ಮಾಡಿಬಿಟ್ರೆ ಮುಗಿದೋಯ್ತು ರೀ. ಓಕೆ, Cp is equals to C1 plus C2 plus C3. Okay, and again this is an important derivation for 5 marks. Okay, ಇದು ಕೂಡ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ derivation ರೀ 5 mark ಗೆ. Okay, yes, see, I'll explain this once again. Let us consider C1, C2, C3 are the 3 capacitors which are connected in parallel. Okay, now V is the applied potential. V is applied potential. Because of this potential, different amount of charges are stored on different capacitors. Okay, so that Q1 is the charge on C1, Q2 is the charge on C2, and Q3 is the charge on C3. So that the amount of charge developed to Q is equals to Q1 plus Q2 plus Q3. Okay, we have C is equals to Q divided by V, and Q is equals to C. Q1 is equals to C1V, Q2 is equals to C2V, and Q3 is equals to C3. C1V plus C2V plus C3V. Okay, now this Q1, C1V1, sorry, C1V, Q2, C2V, Q3, C3V. Substitute money. C1V plus C2V plus C3V. You can take V common. It is sum of the individual capacitances. C1 plus C2 plus C3. Now the entire combination, ಇದು ಪೂರಾ ಕಾಂಬಿನೇಷನ್ ಅನ್ನು ತೆಗೆದುಬಿಟ್ಟು ಒಂದೇ ಒಂದು ಕೆಪಾಸಿಟರ್ ನ ಅದಕ್ಕೆ ನಾವು ಇಕ್ವಿವಾಲೆಂಟ್ ಕೆಪಾಸಿಟರ್ ಅಥವಾ ನೆಟ್ ಕೆಪಾಸಿಟರ್ ಆರ್ ಕಂಬೈನ್ಡ್ ಕೆಪಾಸಿಟರ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಸೊ Q equals to V into C1 plus C2 plus C3. Okay, then we have this Q equal to Cp into V. From equation 3 and 4, CPV is equals to V into C1 plus C2 plus C3. Therefore, Cp is equals to C1 plus C2 plus C3. Okay, thus the effective capacitance of the parallel capacitors Cp is equals to sum of individual capacitances. Cp is equals to C1 plus C2 plus C3, that is sum of individual capacitances. I hope you understood this. Okay? Yes. Now, some important point. Effective capacitance. Effective capacitance in parallel combination is greater than the greatest of the combination. Andre, for example, C1 is 1, C2 is 2, C3 is 5 ಅಂತ ನೀವು ತಗೊಂಡ್ರೆ ನಾವು ಯೂಸ್ ಮಾಡಿರೋದ್ರೊಳಗಡೆ ದೊಡ್ಡದು ಯಾವುದು? C3 is 5. Then so C1 is 1 plus C2 is 2 plus C3 is 5. 1 plus 2 is 3, 3 plus 5 is 8. Therefore, it is greater than the greatest of the combination. Okay? It is greater than the greatest of the combination. Next, for two capacitors in parallel, we have Cp is equals to C1 plus C2. Okay? ಎರಡು add ಮಾಡಿದ್ರೆ ಮುಗಿದೋಯ್ತು. Next, for n identical capacitors in parallel. For n identical capacitors in parallel. Identical means all of them are having the same value of C. That's what C is. C1 is C, C2 is C, C3 is C, plus 1, Cn is C. That is equals to Cp is equals to n into C. Means how many capacitors are there? When you multiply by those many capacitors into the value of each capacitance, you will get the Cp. Cp is equals to n into C. Okay, I hope you understood this. Okay, now we move on to the next, that is called energy stored in capacitor. Energy ಏನಾಗುತ್ತೆ, ಯಾಕೆ ಸ್ಟೋರ್ ಆಗುತ್ತೆ, ಏನು ಅನ್ನೋದನ್ನ ನೋಡಬೇಕು. ಓಕೆ, yes, that is derivation for energy stored in capacitor. Okay, capacitor ಒಳಗಡೆ ಎಷ್ಟು ಎನರ್ಜಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ derivation ಮಾಡ್ತೀವಿ. Okay, that is derivation for energy stored in capacitor. Okay, then you can ask how the energy is stored in capacitor. Energy ಯಾವ ತರ ಅದು ಅಕ್ವೈರ್ ಮಾಡುತ್ತೆ, ಎಷ್ಟು ಎನರ್ಜಿನ ಅಕ್ವೈರ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. Okay, that here is the derivation. Adhe illi derivation. Okay, now energy stored in capacitor. First, capacitor alli yav tara energy store ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನೋಡೋಣ. ಆಮೇಲೆ ಏನಾಗುತ್ತೆ, ಲೆಟ್ಸ್ ಕನ್ಸಿಡರ್. ಓಕೆ, ಆಮೇಲೆ ಏನಾಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ ನಾವು, ಅಲ್ವಾ? ಸಿ ಕನ್ಸಿಡರ್ ದಿಸ್ ಇಸ್ ಅ ಕೆಪಾಸಿಟರ್. ಇದನ್ನ ಒಂದು ಕೆಪಾಸಿಟರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. ಅದರೊಳಗಡೆ ಪಾಸಿಟಿವ್ ಪ್ಲೇಟ್ ಇರುತ್ತೆ ಮತ್ತೆ ನೆಗೆಟಿವ್ ಪ್ಲೇಟ್ ಇರುತ್ತೆ. ಓಕೆ, assume that initially the capacitor is uncharged. ಓಕೆ, ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ starting initially when you connected this is uncharged. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ನಾವು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅನ್ನೇ ಕೊಟ್ಟಿಲ್ಲ. ಕನೆಕ್ಟ್ ಮಾಡೋದಕ್ಕಿಂತ ಮೊದಲು ಅಥವಾ ಕನೆಕ್ಟ್ ಮಾಡಿ ಸ್ವಿಚ್ ಆನ್ ಮಾಡೋದಕ್ಕಿಂತ ಮೊದಲು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ನ ಅಪ್ಲೈ ಮಾಡೋದಕ್ಕಿಂತ ಮೊದಲು ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಇಟ್ ಈಸ್ ಅನ್ಚಾರ್ಜ್. ನೆಕ್ಸ್ಟ್, ಡ್ಯೂರಿಂಗ್ ದ ಪ್ರೊಸೆಸ್ ಆಫ್ ಚಾರ್ಜಿಂಗ್ ದ ಕೆಪಾಸಿಟರ್, ಕೆಪಾಸಿಟರ್ ನ ಚಾರ್ಜ್ ಮಾಡತಕ್ಕಂತ ಟೈಮ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ವಾಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಹ್ಯಾಪನ್ ವೆನ್ ಯು ಚಾರ್ಜ್ ದ ಕೆಪಾಸಿಟರ್? ಓಕೆ, ಡ್ಯೂರಿಂಗ್ ಚಾರ್ಜಿಂಗ್ ದ ಕೆಪಾಸಿಟರ್, ಕೆಪಾಸಿಟರ್ ನ ಚಾರ್ಜ್ ಮಾಡತಕ್ಕಂತ ಟೈಮ್ ಒಳಗಡೆ, ಸಿ ಹಿಯರ್, ಇದು ಪಾಸಿಟಿವ್ ಪ್ಲೇಟ್ ಅಲ್ವಾ, ಇದು ನೆಗೆಟಿವ್ ಪ್ಲೇಟ್ ಅಲ್ವಾ, ಈ ನೆಗೆಟಿವ್ ಪ್ಲೇಟ್ ಇಂದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡಬೇಕು against attraction. Okay, and these positive charges has given to the positive plate. Okay, it is given to positive plate against repulsion. Okay, ಅಥವಾ ಚಾರ್ಜಿಂಗ್ ಯಾವ ಪ್ರೊಸೆಸ್ ನಡೆಯುತ್ತೆ ಅಥವಾ ಚಾರ್ಜಿಂಗ್ ಆಗಬೇಕಾದ್ರೆ ಏನ್ ನಡೀತಾ ಇರುತ್ತೆ? ಸಿ, ಈ ನೆಗೆಟಿವ್ ಪ್ಲೇಟ್ ಅಲ್ವಾ ಇದು ಪಾಸಿಟಿವ್ ಪ್ಲೇಟ್ ಅಲ್ವಾ, ಈ ನೆಗೆಟಿವ್ ಪ್ಲೇಟ್ ಇಂದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡಬೇಕು. We have to remove the positive charges from negative plate. Okay, you know that there is an attraction between negative and positive. So, easily remove ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ ರೀ ಅದನ್ನ. I cannot remove that positive charge easily from a negative plate. It's a quite natural one. I can't remove a positive from a clutched negative charge because of attraction. Because of that, I need to do the work. Okay, and also I cannot give this removed positive charge to the positive plate. Remove ಮಾಡಿರ್ತಕ್ಕಂಥ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಪಾಸಿಟಿವ್ ಪ್ಲೇಟ್ಗೆ ನಾನು ಕೊಡೋಕ್ಕಾಗಲ್ಲ. ಅಗೇನ್ಸ್ಟ್ ರಿಪಲ್ಷನ್, ಅದಕ್ಕೂ ನಾನು ಏನು ಮಾಡಬೇಕು, ವರ್ಕ್ ಮಾಡಬೇಕು. This work is stored as the energy in the capacitor. ಹಾಗಾಗಿ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಅದು ಕೆಪಾಸಿಟರ್ ಒಳಗಡೆ ಎನರ್ಜಿ ಆಗಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. ಐ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟುಡ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಎಲ್ಲ ನೆನ್ಪಿಡ್ಕೊಳ್ರಿ. ಓಕೆ, ಐ ಆಮ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ರೈಟ್ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್. ಪ್ಲೀಸ್ ಡು ರಿಮೆಂಬರ್, ಐ ಹ್ಯಾವ್ ಟು ರಿಮೂವ್ ದಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಫ್ರಮ್ ದ ನೆಗೆಟಿವ್ ಪ್ಲೇಟ್. ಸೊ it is against the attraction, work has to be done, and giving this positive charge to the positive plate, it again work has to be done against the repulsion. Okay, so that the work has to be done, and that work done is stored as energy. ನಾವೇನು ವರ್ಕ್ ಮಾಡಿರ್ತೀವಲ್ಲ, ಆ ಮಾಡಿರ್ತಕ್ಕಂಥ ವರ್ಕು ಕೆಪಾಸಿಟರ್ ಒಳಗಡೆ ಎನರ್ಜಿ ಆಗಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. Okay, yes, you need to remember all these things, and you need to write all those things. Okay, ಇದನ್ನ ನಾನು ನೆನಪಿಟ್ಕೋಬೇಕು. Okay, ಫಸ್ಟ್ ನಾನು ಇಲ್ಲಿ ಏನು ಬರೀತೀನಪ್ಪ ಅಂತಂದ್ರೆ, ಕೆಪಾಸಿಟರ್ ಇಸ್ ಇನಿಷಿಯಲಿ ಅನ್ಚಾರ್ಜ್. ಇನಿಷಿಯಲಿ ಏನಾಗಿರುತ್ತೆ, ಚಾರ್ಜ್ ಇರೋದಿಲ್ಲ. Okay, yes, when potential difference is applied. Okay, initially capacitor is uncharged. Capacitor ಏನಿರುತ್ತೆ, uncharged ಇರುತ್ತೆ. Okay, when potential difference V is applied, okay, Q is charge developed on the capacitor. Okay, Q is the charge developed on the capacitor. Okay, yes, Q is charge developed or charge acquired by ಕೆಪಾಸಿಟರ್ ಅಂತ ಅನ್ಕೊಂಡು. ಸಿ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ, ಈಗ ಫಸ್ಟ್ 0 ಇರ್ತದೆ, ಆಮೇಲೆ ಕ್ಯೂ ಇರ್ತದೆ. ಇಫ್ ಯು ಅಸ್ಯೂಮ್ ದಿಸ್ ಆಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕ್ಯೂ ಮ್ಯಾಕ್ಸ್ ಅನ್ಕೊಂಡ್ರೆ ಈ 0 ಮತ್ತೆ ಕ್ಯೂ ನಡುವೆ ಯಾವುದೋ ಒಂದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಸ್ಟೇಟ್ ಇರುತ್ತೆ. ಯು ಹ್ಯಾವ್ ಸಮ್ intermediate state. Okay, assume that in that intermediate state this q dash is the charge developer. Okay, even ankodekori q dash is the small developed charge anta ankoni athwa dq dash anta ನೀವು consider ಮಾಡ್ಕೊಳ್ಳಿ. Okay, yes, now you know this small amount of the charge ಅಂತ consider ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay, now at any intermediate state dq dash is the charge dq dash is the charge developed on the capacitor. Okay, yes, so that you know that we have to move a small charge from negative to positive plate. Okay, therefore work done for this, you know that work done is equals to charge into potential. Okay, ಆ potential ಅನ್ನು v dash ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಆ ಚಾರ್ಜ್ ಡೆವಲಪ್ ಅನ್ನು ನೀವು dq dash ಅಂತ ತಗೊಳ್ಳಿ. therefore dw is v dash into dq dash. Okay, that is going to be v dash into dq dash. alva? Yes, now you know that c is equals to q by v. C equals to q by v. Now if charge developed is q dash and potential is v dash, which implies that v dash is equals to q dash upon c. Okay, immediately v dash is equals to q dash upon c irutte alvari. Now this small work done dw is equals to q dash by c into dq dash. Okay, q dash divided by c into dq dash. Okay, now ivaga ನಾನು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿದೆ, ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಸ್ಟೇಟ್ 0 ಇಂದ q ಅದರೊಳಗಡೆ ಯಾವುದೇ ಒಂದು dq dash ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ it is a small charge. Then v dash is small potential. Okay, v dash is small potential. ಇದಕ್ಕೆ ನಾವು ಮಾಡಬೇಕಾಗಿರೋ ಕೆಲಸ ಸ್ಮಾಲ್ ವರ್ಕ್ ಡನ್. ಇವಾಗ ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಇವಾಗ ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ ನಾವು ಇವಾಗ ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ in transferring that entire charge from 0 to q, from negative to positive. Okay, now total work done in transferring charge q, okay, from negative to positive plate. Okay, from negative to positive plate is, you know that integration of dw is equals to integration of 0 to q dash by c dq dash. Integration and differentiation gets cancelled out. This work done is equals to integration differentiation cancel, what remains is work done. Now 1 by c, you have to integrate q dash with respect to d. Okay, integration of q dash with respect to d. You know that same thing. Lane मजा इधर इधर dash रो power one अनको बाढ़ रो इधर dash रो dq dash. Integration of x raised to n dx is equals to x raised to n plus 1 divided by n plus 1. Similarly, it is 1 by c. Integration of q dash is q dash whole raised to 1 plus 1 divided by 1 plus 1, where limits running from 0 to q. Okay, that is equals to 1 upon c. ಇದನ್ನ ಈ ಕಡೆ ತಗೊಂಡ್ಬಿಡಿ 2c into q dash limit running from 0 to q. ಅಂದ್ರೆ ಎಲ್ಲಿ q dash ಇದೆ ಅಲ್ಲ ಅಲ್ಲಿ q ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ upper limit, it is q square minus 0. Therefore, work done is equals to q square divided by 2c. Our tending ಆಗಿರುತ್ತೆ. That is q square by 2c. Now, this work done is stored as electrostatic potential energy. Therefore, you have U is equals to Q square divided by 2C. This is the required expression. Okay, and yet again, this is important for final. Okay, ಅರ್ಥ ಆಯ್ತಲ್ಲ ನಿಮಗೆ? ನಾನು ಅವಾಗ ಇದಕ್ಕೆ ಡೈರೆಕ್ಷನ್ ಬರೆಯೋದಕ್ಕಿಂತ ಮೊದಲು ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೆ. ನೆಗೆಟಿವ್ ಚಾರ್ಜಿಂದ ಪಾಸಿಟಿವ್ನ ರಿಮೂವ್ ಮಾಡಿ ಆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜನ್ನ ಪಾಸಿಟಿವ್ ಪ್ಲೇಟ್ಗೆ ಕೊಡಬೇಕು ಅಲ್ವಾ? ಅದು ಕೊಡ್ತಾ ಇರಬೇಕಾದ್ರೆ ವರ್ಕ್ ಮಾಡಬೇಕು. ಅದೇ ವರ್ಕ್ ಅನ್ನು ಎನರ್ಜಿಯಾಗಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸಿ 0 ಸ್ಟಾರ್ಟಿಂಗು ಕ್ಯೂ ಫೈನಲ್, ಇವೆರಡರ ನಡುವೆ ಸಮ್ ಡಿ ಕ್ಯೂ ಡ್ಯಾಶ್ ಅಂತಕ್ಕಂಥದ್ದು ಒಂದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಸ್ಟೇಟ್. ದಟ್ ಈಸ್ ಆರ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಸ್ಟೇಟ್. ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಓಕೆ ವಿ ಹ್ಯಾವ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು v dash into dq dash. ಓಕೆ, ಯಾಕಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿರುತ್ತೆ ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಚಾರ್ಜ್ ಇಂಟು ಪೊಟೆನ್ಷಿಯಲ್, ಪೊಟೆನ್ಷಿಯಲ್ ಇಂಟು ಚಾರ್ಜ್. ಹೊಸ ಡಿಗ್ರಿ ಹ್ಯಾಂಡಿ. ನಾವು ಯು ನೋ ದಟ್ c equal to q by v. c equals to q by v ಗೊತ್ತಿರುತ್ತೆ. ನಾವು c is equals to q dash by v dash. ಓಕೆ, ಯಾಕಂದ್ರೆ q dash is the charge developed and v dash is the potential. ಓಕೆ, ಹಾಗಾಗಿ ಈ v dash ನ q dash by c ಅಂತ ನಾನು ಬರೀತೀನಿ. ಓಕೆ, q dash divided by c ಅಂತ ಬರೀಬಹುದು ಅಲ್ವಾ? ಎಸ್. Now what happens? This is the small work. Therefore, total work done in transferring a charge q from negative to positive plate is integrate this integration 0 to q, q dash per c dq dash. Okay, now work done is equals to 1 by c into 0 to q because c is constant dq dash q dash. Okay, ಇದನ್ನ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಿದ್ರೆ q ಇದೆ, q raised to 1 plus 1 divided by 1 plus 1 ಬರೀತಿದ್ವಲ್ವಾ? ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ q dq ಇದಿದ್ರೆ ಓಕೆ, ಅದೇ ತರ it is q square by 2. then here also we have q dash by 2, q dash ಇದರಲ್ಲಿ q ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ I'm sorry. Okay, see q dash ಇಲ್ಲಿ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ q ಸ್ಕ್ವೇರ್ ಬರುತ್ತೆ. ನಾನು ಇಲ್ಲಿ q dash ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕಿತ್ತು ರೀ. ಓಕೆ, q dash square running from 0 to q. Okay, q dash 1 raised to 1, it is q dash square from 0 to q. ಹಾಗಾಗಿ q dash ಜಾಗದೊಳಗಡೆ q ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, 0 ಜಾಗದೊಳಗಡೆ 0 ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. therefore work done is equals to q square divided by 2c, and this work done is stored as electrostatic potential energy. Alva? Yes, we know that q is equals to ನಾವೇನು ಬರೀಬಹುದು ರೀ, ಚಾರ್ಜ್ ಅನ್ನ cv ಅಂತ ಬರೀಬಹುದು ಅಥವಾ c is equals to q by v ಅಂತ ಬರೀಬಹುದು. therefore we can get the different forms. u is equals to this q can be written as cv square divided by 2c. C square V square divided by 2c. Therefore, U is equals to CV square divided by 2. This is also the formula in terms of C and V. Okay. Now, ಈಗ C ಜಾಗಕ್ಕೆ Q by V ನ substitute ಮಾಡಿ. V is equals to Q square divided by 2 into C is Q by V. This is Q divided by V. 1Q gets cancelled out. This V goes to the numerator. That is Q V divided by 2. Okay. That is QV divided by 2. Okay. Or in other words, we can write U is equals to half into charge into potential. Okay. These are the different forms of the energy. Okay. Then the last topic of this lesson, that is uses of capacitors. Capacitors use ಏನು ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀರಾ? Okay. See, the capacitors are used to store the energy, electrical energy. See, you have this energy, right? Electrostatic potential energy. ಅದೇ ತರ ಅದನ್ನ ಎನರ್ಜಿ ಸ್ಟೋರ್ ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Capacitors are used to store the charges. Next, capacitor are used to separate the AC from DC. ಅಂದ್ರೆ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ನ ಡೈರೆಕ್ಟ್ ಕರೆಂಟ್ ಇಂದ ಸಪರೇಷನ್ ಮಾಡೋದಕ್ಕೆ ಕೆಪಾಸಿಟರ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ. ಫಿಲ್ಟರ್ಸ್ ಸರ್ಕ್ಯೂಟ್ ಅಂತ ಕರೀತೀವಿ. ಇನ್ ಫಿಲ್ಟರ್ಸ್ ಸರ್ಕ್ಯೂಟ್ ದ ಕೆಪಾಸಿಟರ್ಸ್ ಆರ್ ಯೂಸ್ಡ್. ಓಕೆ. ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀವಪ್ಪ ಅಂತಂದ್ರೆ ಕೆಪಾಸಿಟರ್ ಆರ್ used to control the amount of alternating current in the circuit. Okay. Alternating current na control ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay. And also the capacitor are used to produce the uniform electric field. Okay. Electric field uniform ಅಲ್ಲಿದ್ದಾಗ uniform produce ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay. Capacitor are used to store energy. They are used to store a charge. They are used to separate AC from DC. They are used to produce uniform electric field, and they are used in filter circuits to separate the AC from DC. Okay. I hope you all understood this. Okay, my dear all, this is the end of this lesson, that is electric potential and capacitance. Okay. In the next class we will solve with the numericals. Thank you very much.